Hello, Algebra 2. Welcome to the first lesson in Unit 7 Trigonometry. This is just a quick review of everything that you should know from Algebra 1 and Geometry, okay? So nothing that has to be written. I'm just going to walk you through each of these things, and if there's anything that you're really unsure of, just put a star next to it, and we'll go over it tomorrow in class, okay? So the first thing is review of right triangles. A right triangle means you need to have a 90 degree here. And then you have two sides of the triangle, and whatever side is opposite that 90 degree is your hypotenuse, which brings us to the Pythagorean theorem. Your a squared plus b squared equals c squared. C squared should always be the hypotenuse, okay? That hypotenuse is also always your longest side of your triangle, okay? And hopefully we remember that the sum of all three angles inside the triangle is 180. So in geometry, you also learned about SOHCAHTOA. SOHCAHTOA is the abbreviation for sine, cosine, and tangent. So SOH is sine theta would equal opposite over hypotenuse, okay? CAH is cosine theta, meaning the angle, is adjacent over hypotenuse, and TOA is tangent theta, which is opposite over adjacent. That theta can be represented in different Greek symbols, theta, beta, mu. Okay, it's just a different way of saying it, just like we use X, Y, and Z. Now, when you're doing trig, a lot of students don't understand which side is the opposite, which side is the hypotenuse, which side is the adjacent, because they do change depending upon where your angle measurement is. So if you have this triangle, excuse me, sorry, and the angle measurement is down here, then immediately draw an angle opposite. Once you mark this and go opposite this angle, that literally is your opposite. And you already know opposite the 90 degrees or hypotenuse, then this must be the adjacent, okay? If your angle measurement that's given is up here, mark that angle. Opposite that angle would be your opposite side. Still opposite the 90 degree is your hypotenuse, which would mean your adjacent is now on this side, okay? All right, the calculator, there's just two things to remember in the calculator, that you should always go to your settings in the calculator. They must be in degrees in order to do any trig functions, okay? Once we get into graphing, we need to make sure the graphing section is in radians, but for the calculator page, it needs to be in degrees. And if you're ever asked to put something in degrees, minutes, and seconds, there is a DMS function in your calculator that will convert everything. Instead of getting a decimal answer, it will give you something in degrees, minutes, and seconds, okay? It'll have a little degree symbol. 1 tick stands for minutes, 2 ticks stands for seconds, okay? Inverse trig is when, instead of trying to find a side, as in the opposite, the hypotenuse, or the adjacent, you're trying to find the actual measure of the degree here, of the theta, okay? So if you have sine theta equals opposite over hypotenuse, and you know your opposite and you know your hypotenuse, and you're trying to find the actual degree measure, then you just type it into your calculator using inverse trig. You look for the button that has inverse sine. It'll type, once you hit the button, it'll come up sine to the inverse, to the little -1, and then a parenthesis, and you would put the fraction of side over hypotenuse, and when you hit enter, it will give you the degree measure, okay? Now, for real world, you're often given problems like shadows or tree height or a wire that goes to a pole. I remember one of you guys talking about it in class when I mentioned that we were going to be going to trig. One of you was talking about the flying a kite and the length of the wire and whatnot, okay? So the ground is always set parallel so that you can remember your alternate interiors are congruent, okay, when cut by a transversal back in geometry. So if this is my triangle right here, the ground measuring up is your angle of elevation, which makes sense. When you elevate things, you bring them up, okay? If you were given the angle of depression, meaning parallel to the ground, you're looking down from the top of a building, then this angle is not inside your triangle. You need it to be. So this angle of depression would be equal to the angle of elevation because of what you remember from geometry. Okay? All right, then we have the sign chart, whether something is positive or negative. Okay? So we remember this by all students take calculus. Okay? Or Alvin, Simon, Theodore, chipmunks. So we start at quadrant 1 is A, quadrant 2 is S, quadrant 3 is T, and quadrant 4 is C. All students take calc. What does that mean? Well, if you're going right on the x-axis, that's positive. If you're going up on the y-axis, that's positive. Well, you're going to find out that the x-axis represents cosine theta, and the y-axis represents sine theta. So you're really talking about positive cosine this way, and positive sine this way. Okay? So right is a positive cosine, up is a positive sine. So that means that cosine is positive and sine is positive in the first quadrant. And hopefully you all remember that sine over cosine equals tangent. So if I have a positive over a positive, I get positive. So tangent is also positive in the first quadrant. That's why we have an A, because all trig functions are positive. In quadrant 2, if I'm going left on the x-axis, I'm really going to negative cosine. If I'm going up, that's positive sine. So what's the symbol that is positive? S. So that means only the trig function sine is positive. Because if cosine is negative, and this is positive, if I put a negative on here, then my tangent will also be negative. So only sine is positive here. So we got all are positive in this quadrant, only sine is positive in this quadrant. This quadrant, if I go left on the x, that really means negative on cosine. If I go down on the y, that really means negative on sine. So I have a negative cos, a negative sine. Well, if tangent means negative sine over negative cosine, negative divided by negative is positive. Only tangent would be positive in that section. So T. Right on the x is a positive cos. Down on the y is a negative sine to get into this quadrant. So cosine is positive. Sine is negative, which brings me back to this. If sine is negative and cosine is positive, then I'm still going to get a negative tangent. So only cosine is positive. That's where your all students take calc comes from. Okay? All right. Then we come into unit circle. So like I said, alphabetically, x, y, the x is going to now be your cosine. The y is now your sine. If we're dealing with a circle that has a radius of 1 unit, then this is 1, this is 1, this is -1, and this is -1. If I were to make a circle, then my x-axis, which is really cosine theta, this ordered pair is 1, 0. This ordered pair is 0, 1. If I go left 1, it's -1, 0. If I do not go right or left and I just go down, that is 0, -1. These are just your x, y coordinates. But it's really not x and y anymore. It's cosine and sine. The y-axis is sine theta, so it's cosine and sine and so on. Okay? So this is going to help us when we fill out an exact value chart this week. Okay, so try to remember this. Okay, again, here's our quadrants. 1, 2, 3, 4. You know a circle is 360 degrees. So we always start at 0. So that's called the initial ray. If I go up to here, that is a 90 degree. If I go a little further, just estimating that, maybe that's 100 degrees. Okay, but it's a positive 100 degrees because I'm going up. Wherever I stop is called the terminal ray. You can go positive or you can go negative if you go in the opposite direction. So that's what we call coterminal. They share a ray. So if I go past 90 degrees and I go into here, I'm not quite at 180 degrees. So if I say that this is 140 degrees, then that means it is a positive 140, because I start at the initial going positive. That is equal to, if I were to start at 0 and go negative, well, this whole circle has to equal 360 degrees. So 360 degrees minus 140 is 220. But I went negative, so a coterminal to a positive 140 would be a negative 220. Okay? There's an infinite number of coterminal rays that you can calculate. Okay? So here's another one. If I went down, that's negative. If I tell you this is down 40 degrees, then what is another coterminal? Well, a full circle, if I went positive, a full circle is 360. I can't make it to 360. So 360 minus 40 is 320 degrees. And I would be going this way, so that is a positive 320. So negative 40 and positive 320 are coterminals. Well, I could also do a coterminal as negative 360 the full way around plus another 40 degrees. So negative 360 and another negative 40 degrees is negative 400 degrees. So it's just meaning that you're going to keep going around in circles until you make the full circle and end on that terminal ray. Okay, so we'll do more practice with that. There's an eMath instruction video. Yes, I'm sure you remember eMath instruction from Algebra 1. So there's an eMath instruction video that does a lot of practice with that you're going to be doing next. Okay? Then we get into bow ties. This is quite extensive, and we're going to be using this a lot. So looking at this, it probably looks crazy, but we're going to utilize this quite a bit. So don't get scared. I know it looks crazy. Reference angles. Reference angles are known as bow ties. They root down to 180 degrees and 360 degrees, okay? So that means if I were to go up to a 30-degree angle right here, this is a reference angle, okay? If I were to tell you to draw a terminal ray of 140 degrees, I need to, wherever this terminal ray stops, I have to root it back down to 180. So what's left between that is 40 degrees. That means 40 degrees is my reference angle. If I were to start at the initial and go all the way around to 240 degrees, I don't ever root to this. I root back up to this 180. Well, what's the difference between 180 and 240 is 60 degrees. That means this little piece is 60 degrees. That's another reference angle. So I've drawn them all a little bit different sizes just to show you. But basically they call it bow ties because every reference angle is always the little piece that roots back. So it's a less than 90, less than 90, less than 90, less than 90. That's why over here it shows it's always between 0 and 90 degrees, or acute. They are always acute angles. They're never negative, and they always root to 180 and 360. So here's our last one. If I draw a 340 degree angle, then I root straight back up to this horizontal cosine axis. What would be left is 20 degrees by the time I get there. So 20 degrees would be my reference angle. Okay? So that's everything you need to know for trig. One last little thing, I know you had this in algebra, in geometry, and it is on your reference sheet. So pi is always equal to 180. If you ever want to change degrees to radians, if I gave you 30 degrees, you would multiply it by pi over 180 to find out what's left in radians. This would cross cancel, this cross cancels, so it is pi over 6. If you want to go from radians to degrees, you multiply by 180 over pi. The pi's cancel, this can cross cancel, and you're going to wind up with 270 degrees. That means 3 pi over 2 radians equals 270 degrees. Means 30 degrees equals pi over 6 radians, and this we'll do more of later in about 2 or 3 days. Okay? So that is a review of the basics that you need for trig in less than 20 minutes. Okay? So we'll do some application of all of this over the next few days. Have a good night.